All right, let's dive into one of the most extreme animals on the entire planet. We're talking about a tiny shrimp that snaps its claws so fast it creates a bubble that's actually hotter than the surface of the sun. I mean, how is that even possible? Let's get into it.
So here it is, the pistol shrimp. And believe me, it is tiny. We're talking only about 4 centimeters long, but you absolutely should not let its size fool you. Now look at its claws, or chela. See how they're asymmetrical? One is just a normal little pincer, but the other? Well, the other one is this oversized biological weapon. And that single claw is what makes this little guy one of the loudest and most powerful animals in the ocean.
And that really is the central mystery here, isn't it? How on earth does an animal this small generate such unbelievable force? We're talking about temperatures hotter than the sun and a sound louder than a gunshot. It just sounds completely impossible, but nature is a master engineer. So to really get it, let's break down the numbers. Okay, first up, the sound. The snap from its claw hits a deafening 218 decibels. Now, to put that in perspective for you, a gunshot is somewhere around 140 to 170 decibels. So yeah, this tiny shrimp is significantly louder than a bullet firing.
Then you've got the heat. For just a split second, a fraction of a second, the snap generates this little pocket of heat reaching 4,800 degrees Celsius. That is nearly as hot as the surface of the sun. It's an almost unimaginable temperature for a living creature to be able to produce.
And you know what? It all starts with pure, unadulterated speed. The shrimp cocks its claw like the hammer of a gun and snaps it shut at an incredible 97 kilometers per hour. That's about 60 miles per hour. This single, ridiculously fast motion is the trigger for everything else that follows.
So, how do all those insane numbers add up? Well, the answer is in some really fascinating physics. Because the raw power of this snap isn't what you might think it is. Let's start to unravel this natural superweapon.
First things first, we've got to clear up a big misconception. That massive bang you hear, it is not the sound of the two halves of the claw physically smacking into each other. The actual impact is almost silent. The real weapon is something way more sophisticated.
The real secret is in the claw's design. You see, there's a small plunger on one side that fits perfectly into a socket on the other. When that claw snaps shut, this plunger fires a jet of water out of the socket at incredible speed. It's basically acting like a tiny, high-powered water pistol.
And this super high-speed water jet creates a phenomenon called cavitation. As the water accelerates, the pressure inside it drops so low, so fast, that the water literally vaporizes. It forms a tiny bubble that's essentially a vacuum. And that bubble is the source of all the shrimp's power.
You know, this is just a brilliant way to think about it. The bubble forming is like the lightning bolt superheating the air and creating a low-pressure channel. And that deafening snap? Well, that's the thunder. It's caused by water rushing back in to collapse that vacuum bubble at supersonic speeds. It's microscopic thunder.
Okay, so the power comes from a collapsing bubble. We've got that. But what's so special about this bubble? It turns out this isn't just any old, simple, spherical bubble. Its unique shape and its structure, that's the real secret.
The mind-blowing physics here comes from the fact that this thing isn't just a sphere. No, the shrimp actually engineers a perfect, spinning, donut-shaped structure, a cavitating vortex ring. I want you to think of it like a microscopic smoke ring, but instead of smoke, it's made of a vacuum, and it's spinning with immense force.
So here's the play-by-play, and it all happens in the blink of an eye. First, the plunger fires the jet. Then, the edges of that jet immediately curl up, forming a swirling vortex. The intense spinning at the core of this vortex drops the pressure so low that the water vaporizes into a bubble ring. This ring then shoots away from the claw, and then, finally, it collapses on itself with incredible explosive force.
And these simulations show the connection just perfectly. On the left, you can watch as those swirling vortex structures form. Now look over the right, you can see the cavitation bubble, that black shape, appearing right in the middle of that vortex. The physics are completely linked. You don't get the weapon without the vortex.
And that collapse is just devastating. The simulations show it releases a pressure pulse that peaks at 80 bar. That's about 80 times the atmospheric pressure at sea level. It is this powerful shockwave that actually stuns or even kills the shrimp's prey. It's a true precision-guided sonic weapon.
Okay, so that brings us to the next big puzzle. With all of that heat, all of that pressure, and that massive concussive force being generated right at its own fingertips, how does the claw not just shatter itself with every single snap? Right, the plunger is basically at ground zero for this entire event, yet it can fire over and over and over again without breaking. The answer isn't just a strong shell, it's some of the most sophisticated biological engineering you can find anywhere in nature.
A look under a scanning electron microscope reveals the secret. Okay, so on the right, that's a normal part of the claw. It looks pretty solid and uniform, but on the left, a cross-section of the plunger shows something else entirely. It's not a solid piece at all. It's a highly specialized, multi-layered composite material, almost like something out of an advanced materials lab.
And this schematic here really breaks it down for us. The plunger is a natural sandwich composite, and it has these distinct layers that have been specifically evolved for what researchers call thermomechanical damage tolerance. In other words, each layer has a specific job in protecting the shrimp from its own power.
Now this is where the design gets truly ingenious. The outer and inner layers are packed with calcite, a hard, almost rock-like mineral, which provides stiff armor. But that middle layer, it's made of chitin, the same tough but flexible stuff you find in insect exoskeletons. And here, it's super porous, creating this soft, spongy core. This core acts as a brilliant shock absorber and a heat insulator, protecting the shrimp's own tissues from its own blast. Just brilliant.
So, this incredible combination of fluid dynamics and material science, it isn't just some evolutionary curiosity. It holds some really powerful lessons for human technology and innovation.
And researchers are already looking into how to mimic these principles. I mean, imagine using precisely targeted cavitation bubbles as a kind of non-invasive surgery to destroy tumors. Or designing armor and protective gear based on the claw's amazing layered structure. The shrimp's mastery of physics could even lead us to new ways to purify water, or maybe even create clean energy.
So the really crucial takeaway here is that nature is so often the world's most innovative engineer. The pistol shrimp is living proof of that. It's a creature that has mastered sunluminescence, vortex physics, and composite materials. Which really just leaves us with one final question to think about. What other revolutionary secrets are just waiting for us hidden in plain sight in the natural world?